Good evening. How are you? So, what about your exams? Have you written well? Are you feeling any tough while studying BEE? So, today I will explain about or I will give some information about some important topics or some important questions. So, maybe I will take 40 or 45 minutes, or maybe it will take 60 minutes also. Okay. So, if you have any questions, you ask me, I will clarify those questions. So, if you are feeling any topic stuff, or if you are feeling any tough topic, please ask me. If time permits, I will explain that. Okay. So, otherwise I will set an example already, maybe already I given a lecture in a Cynohub. I will cite that example, you go through that. Okay. I think because of Corona, you forgot all the topics of BEE. Maybe if I ask a question, what is BEE, some of you will not answer that. Am I right? Tell me. You forgot that abbreviation also. BEE means what? It's a basic electrical engineering. Okay. So, coming 60 minutes or 50 or 60 minutes, so I will tell you what are the important topics and what are the expecting questions from those important topics. Okay. So, you have very less time, am I right? You have only one day, maybe on Monday or Tuesday you have an exam. Okay, you have very less time. So, you have to concentrate on very important topics. Okay. So, do not study all the topics and do not forget all the things. Okay. Some of you will study all the topics and at the time of examinations they will forget all the things. So, concentrate on important topics. Okay. You have to concentrate on important topics and definitely you will pass the examination. Okay. Okay, come. So, totally we have 5 units. Okay. So, unit 1 consisting of DC circuits, unit 2 is AC circuit, unit 3 is it belongs to transformer, unit 4 is different types of electrical machines, unit 5 is the switchgear components. Okay. So, here I will divide each unit into 3 parts, part 1, part 2, part 3. So, in part 1 what are the topics, I will write here. In part 2 what are the topics, and in part 3 also what are the topics, I will write here. And I will give you some questions, I will frame some questions from part 1, part 2 and also from part 3. Okay. If you study any 2 parts, definitely you will pass, you will get very good marks. Okay. So, you have very less time, you have to do a smart work, not hard work. Okay. Smartness. So, okay, unit 1, so it is showing here. So, RLC parameters. Okay, I will write here. Okay. So, part 1 I will take RLC parameter and different types of sources, KCL and KVL. So, KCL is nodal analysis, maybe the application is nodal analysis, KVL is mesh analysis. This is part 1. Okay. For part 2 I will take all theorems. You have 3 theorems, those are Thevenin's theorem, Norton's theorem and superposition theorem. Okay, this is part 2. And what about part 3? I'll take transients. Okay, next time. So, okay, 3 parts. Part 1 consisting of RLC parameters, sources, and KCL and KVL. KCL application is nodal and KVL application is mesh. And second part is theorem and third part is transient. Okay. Now, what are these short answers? Mean 2 marks questions, and what are the long answers? That means 8 marks questions, I'll tell you. So, normally they will ask in 2 marks, define KCL, define KVL, or define Thevenin's theorem, define Norton's theorem, or state, they will state, and also superposition theorem. Okay. Or they'll ask define inductor and its property, or different types of sources, or classify the sources, or definition of KCL and KVL, or statement of theorems. So, those are the short questions from Unit 1. Okay, I am repeating. Classification of sources, okay, and definition of KCL, definition of KVL. While studying KCL, KVL, please study one example, a sample example. Take 1 resistor or 2 resistors and a sample resistor 2 ohms or 4 ohm. Okay, very small problem you have to study. Okay, they will ask define KCL with one example. Okay, likewise. Next, statement of the theorems. Those are all short answers questions. Okay. So, very rarely they will ask transient. So, they will ask like write the formula of current in RL series transient, or write the formula of voltage across the resistor in RL transient. Likewise, they will ask here you will get formula, or they will ask formula in short answer. Yes. 2 marks questions. Okay, okay. You do it to me. Okay, only long answers. Okay, anyway, sorry for miscommunication. I thought that I don't know about the change of question paper. Leave it. Okay. Now come to long answers questions. Okay. So, part 1, part 2 and part 3. So, normally in part 1, your model questions calculate power in total circuit. You have to calculate power and you have to say algebraic sum of the powers is equal to 0. Next problem is it is based on KCL, and next problem is it is based on KVL. Okay, you will get 3 numericals. One is calculate power, you have to show algebraic sum of the powers is equal to 0. Next one, finding of current or finding of voltage at a particular resistor by using KCL or by using KVL. Okay, if they ask use KCL means use nodal analysis. Okay. Use KVL means use mesh analysis. Okay. If they didn't ask about any method, it is easy to use mesh analysis because it is very easy method. Okay. So, if you want to any numericals or solve numericals, please open Cynohub. I have solved so many examples. Okay, I have solved so many examples. I have given practical examples also. Okay, to understand the topic, I have given very practical examples, and I have solved so many numericals based on these 3. Okay. Now, come to here, part 2, we have 3 theorems: Thevenin's theorem, Norton's theorem, and superposition theorem. Okay. Only 2 models. First model is explain particular theorem. Next model is calculate current or voltage at particular parameter using that particular theorem. Okay. That means you have to study theory of the theorem and you have to practice 1 or 2 examples of that theorem. Okay. So, first question, theory question, they will ask explain superposition theorem with an example or explain Thevenin's theorem with an example. Okay. And another model is they will give one circuit and they will ask you to find out some current or voltage by using some particular theorem, that is part 2. And part 3 is we have only 2 circuits, RL circuit and RC circuit. Okay. Now, if possible, read theory of this and possible solve 1 or 2 numericals based on RL series transient and RC series transient. Okay. If you are facing or you are not understanding this topic, transient topic, please open Cynohub. I have explained in easy way. Okay. Okay. Now, part 1, part 2, part 3. You feel maybe transient or difficult one, or some of you will feel theorems or difficult one. Okay. So, in these 3 parts, leave one part and study 2 parts, definitely you will pass. Definitely you will get good marks, not pass. Okay. So, read part 1 and part 2, leave this, no problem. Or take these 2 parts, leave part 1, no problem. Or take 1 and 3 and leave 2, no problem, you will get good marks. Okay. So, this is about first unit. Okay, if you have any questions regarding first unit, please post it, I will explain, or if time permits, I will explain that. Okay, otherwise, I will cite the videos which are in Cynohub. Okay, so that is about unit 1. Next is unit 2. So, unit 2 is having 3 parts. Maybe most of you will feel unit 2 is very difficult one because so many derivations and so many numerical. Okay. So, part 1, first part 1 is calculation of RMS voltage, calculation of average voltage and peak factor and form factor and active power, reactive power and apparent power. This is part 1. Okay. And what is part 2? Circuits. Okay. RL series circuit, RC series circuit, RLC series circuit. These are series circuits. Likewise, RL parallel circuit, RC parallel circuit, RLC parallel circuits. So, this is part 2. And what is part 3? Part 3 is having series, parallel and 3-phase connections, or we can say 3-phase balanced connections or balanced connections. Those are star and delta. Those are star and delta Okay. So, now 3 parts. Okay. Now, definitely we will get one question. That question is calculate RMS value or calculate average value of a given waveform. They have given some sinusoidal waveform or some trapezoidal waveform or some triangular or steppered wave or any random waveform, and they will ask you to find out what is average value and what is RMS value. That is one model from part 1. Okay, definitely you will get one waveform with one waveform to calculate RMS value, average value, and peak factor and form factor. Okay, that is only one question or one model from this. So they will give some waveform, some triangle or trapezoidal, whatever it may be, some square, whatever it may be, and they will ask you to find out RMS, average, and peak factor and form factor. Okay, very important model. Okay, because you will feel second unit is very difficult one. Okay, because so many topics are there. Okay, so now you have to use smartness. You have to use your smartness. You have to select what is the important topic. Okay, based on that you have to study. Okay. Next, coming to second part, that is RL, RC, RLC series circuits, RL, RC, RLC parallel circuits. Okay, how many circuits you have? 1, 2, 3, 4, 5, 6 and 6 derivations and 6 model problems. That's why you will feel second unit is very difficult one because of part 2. Okay, here normally they will not ask RLC series and RLC parallel. So frequently they will ask RL series and RC series. Okay, frequently they will ask. Resistor and inductor are connected in series. Resistor and capacitor are connected in series. Sometimes they will ask parallel. Resistor, inductor are connected in parallel. Resistor, inductor, capacitor are connected in parallel. Okay. So you are feeling this part 2 as very difficult one. Normally most of you will feel. That's why read these 4 topics, RL, RC, RL and RC. You have some derivations. Okay, how to derive some derivations. What is voltage across resistor, what is voltage across inductor, and what is the impedance value, what is the active power, what is the reactive power, what is the apparent power for each circuit. Okay. So if you are feeling very difficult or you are not understanding in textbook, please open a video in a Cynohub. I have explained very easily and very neatly. I have explained step by step what is this and what is that, what is the need of that equation. Likewise, I explained each video or each circuit very neatly. Please open and please see some numericals based on these 4 also. Definitely you will feel second unit is very easy one. After watching the videos, definitely you will feel second unit is very easy one. Okay. So leave this RLC series and RLC parallel. So just read RL series, RC series, RL parallel or RC parallel and see derivations of these 4 circuit and try to solve 1 or 2 numericals. Okay. So from part 2 you will get derivations of each circuit and some numericals, very easy numericals. Okay. Not very critical, very easy. Easy means substitution of the values in a formula. Okay. Next, come to this 3-phase balanced connection. It is star and delta combinations. Okay. Here you will get 2 models. Here also you will get derivations. So what are the derivations? Relationship between line voltage and phase voltage or line current and phase current. Okay, relationship between line voltage and phase voltage, line current and phase current in a star connected system or in a delta connected system. And substitution numericals based on these values. First you have to understand that problem, that numerical. You have to read once or read twice and write the given data step by step. Then write the formula what you know. Okay, based on that, okay, what are the unknown factors? What are the known factors? So what are the formulas you have to use? Likewise, you have to solve. Okay, so you will get so many modal numericals because 4 circuits and so many waveforms, and also 2 another models, that is star and delta connected systems. Okay, so you read any 2 parts, definitely you will get good marks. Leave any one. Okay, read any 2 topics, 2 parts and leave one, definitely you will get good marks. No sir, I'll read all the things means read all the things. If you are getting any doubts, or if you have any doubts, please open Cynohub. Definitely your doubt will be clear. Okay, now I'll go to unit number 3. So what is unit number 3? It is a transformer. Now you are entered into electrical machines. Electrical circuits are completed. Unit number 1 and unit number 2, DC circuits and AC circuit, and unit number 3, 4 and 5 you have entered into electrical machines. Okay, now problem starts from unit number 3. Okay, so normally problem starts from unit number 3. Okay, transformer means so many vector diagrams will be there. Okay, one line will be like this, one line will be like this, one line will be like this. You don't know what are the lines. So in my college, so many students ask about those vector diagrams. Tell me again, tell me again, tell me again. Anyway, come. So part 1, part 2 and part 3. What is part 1? Transformer. Okay. So normally have 2 transformers, ideal and practical transformer. So in that one, so many topics are there. So I'll write it from here. Sorry. Transformer on no load. Transformer on load, and its equivalent circuits and transferring parameters. Before that, what you have to know? Transformer, its advantages and disadvantages. Okay, or you have to know its need or its function or its purpose. Okay, this is the part 1. Part 2 is losses, efficiency and regulation. So that is part 2. And part 3 is auto transformer and 3-phase transformer connections. 3-phase transformer connections. Okay, so that is about your 3 parts of unit number 3. Okay, so before starting the transformer, you have to know about what are the advantages or what is the function or what is the necessity of that transformer in a power system. Okay, so normally they will ask some 4 marks question. Okay, A bit has a 4 marks and B bit has a maybe higher than that. Total is 15 means 11 marks. Okay, likewise A bit is 4 marks or B bit is 11 marks means A bit they will ask what is the function of a transformer in a power system. Okay, so let's come to transformer operation. These two are under operation of a transformer. So very important question. The question is explain the operation of a transformer on no load case. Explain operation of a transformer on load case. Or they will ask another question like this. What is the working of transformer? Or what is the operation of a transformer? Those are very important questions. What is the operation of a transformer? What is the operation of a transformer on no load? What is the operation of a transformer on load with phasor diagrams? Continuation of that question. Okay. If the question is like this, explain operation of a transformer, all of you will write. But what will be there at last? With phasor diagrams. Okay. So, here you will get one model question is working of a transformer on load case and no load case with vector diagrams or phasor diagrams. That means you have to explain this operation under no load, under load case with phasor diagrams. Very important. Very important. Okay, most of you have doubt how to draw a phasor diagram. So many lines, so many angles, so many notations. Okay, so don't worry. Cynohub is here. They will make a easy way to understand. Okay, so just open Cynohub and go to no load operation and load operation. I've explained step by step. Here you have only two headings out there, no load operation and load operation. To get these two headings, I have taken 5 to 6 lessons. Okay, I explained very neatly. Transformer and load case, transformer and loaded case, okay, with phasor diagrams. I have drawn so phasor diagrams very neatly, step by step, by explaining it. Okay, so from this you will not get any problem, you will not get any numerical. They will ask only theory, working of a transformer and no load case and load case. Then where will you get the problem? Here you will get the problem. Transferring of parameters, and also another one is there, induced EMF. So another topic, very important topic is induced EMF derivation and its numericals. Okay, two model of numerical, that is one numerical is based on EMF formula, E is equal to 4.44 F5M Bm. Okay, based on EMF formula, they will give, it is a substitution. Okay, they will give some parameters, you have to find that parameters and substitute in formula, you will get the answer. Very easy numericals you will get. Okay, so one numerical is based on induced EMF, another numerical is based on transferring of parameters, that is referred to primary or referred to secondary. Okay, now what are the model questions from part 1? First model question, working of or operation of a transformer on no load case and loaded case. And second model question, derivation of induced EMF. Okay, and third one, what is the necessity of a transformer and a power system. And fourth one, numericals based on referring parameters. And fifth one, numerical based on induced EMF. So totally 5 models from part 1. Okay, now coming to part 2, 1, 2, 3. Losses is one topic, efficiency is one topic, and regulation is one topic. Okay, now theory questions are 2 theory questions. This is one theory question, another one, this regulation is another theory questions. So the model is, what are the losses in a transformer? Explain in detail, or classify the losses in a transformer, or explain losses in a transformer. You have copper loss, iron loss, stray load losses and dielectric losses. You have to explain one by one. Okay, so that is one theory question. Another theory question is, What is voltage regulation and derive formula? What is voltage regulation and derive formula? Voltage regulation. Okay. Now tell me, what about numerical models? Two numericals. One is to find the efficiency, another one is to find the regulation. If you want to find the efficiency, you need a losses. Okay. If you want to find the efficiency, you need a losses. What is efficiency? It is output by input, that is output by output plus losses. Okay. Now they will give losses value, you substitute in efficiency formula, you will get efficiency. They will give voltage values at no load case and load case, you will get regulation value. Okay. Here what are the models? First model, classify or explain of losses in a transformer. Second model, regulation, based on regulation, and numericals based on efficiency and based on regulation. Okay. So that is about part number 2. And coming to part number 3, you leave this auto transformer, concentrate on this 3-phase transformer connections, because you have done some laboratory experiments on 3-phase transformer connections. You have 4 connections: star to star, star to delta, delta to star, and delta delta connections. Okay. So only one question from 3-phase transformer connection. What is that? So what is the relationship between sending end voltage or secondary voltage and primary voltage in a particular 3-phase transformer connection? In a particular 3-phase transformer connection. So maybe it is a star star or delta delta or star delta and delta star connection. So only one question. So there are some equations I have given very neatly, step by step. I have explained very neatly. You just go through that. You watch only one time, definitely you will understand it. Okay, only one question. What is the relationship between secondary parameters in terms of, or primary parameters in terms of secondary parameters in a particular connection, either star star connection or delta delta connection or star delta connection and delta star connections? Okay. So that is about unit number 3. Okay. If possible, you leave this and you read these 2 parts, definitely you will answer total question. You will get 15 marks. Okay. So here 2 theory questions and 2 numerical models, and here you will get 4 theory questions and 2 numericals. Okay. So that is about unit number 3. Okay. So now I will go to unit number 4. Unit number 4 is having 4 electrical machines. Okay. So one is 3-phase induction motor, another one is single phase induction motor, another one is separately excited DC motor, and another one is synchronous generator. So 4 electrical machines, unit number 4. 3-phase induction motor, single phase induction motor, separately excited DC motor, and synchronous generators. And this synchronous generator is also called as alternators. Here very important machine is 3-phase induction motor. Okay. So very important machine is 3-phase induction motor. You have to read all the topics related to 3-phase induction motor. So your first model question is construction and operation of 3-phase induction motor. Normally, frequently they will ask operation of a 3-phase induction motor. or construction of a three-phase induction motor. Okay. Then they will ask about construction and operation, three-phase induction motor, construction operator. Another important question is slip torque characteristics. Slip torque characteristics. Another one is losses and efficiency. Losses and efficiency, and at last it is speed control. Okay, speed control. Now, construction and operation is one question, or they will ask operation of a three-phase induction motor or construction of a three-phase induction motor with neat diagrams. Okay, remember that, neat diagrams. Next one is slip torque characteristics, and less model is explain losses in a transformer. The slip torque characteristics means they will ask directly draw the slip torque characteristics. You have to draw the slip torque characteristics, that's it. Okay, and speed control, you have 2 or 3 methods of speed control. Okay, so in these 5 topics, so what are the important topics? First 2 are very important. Okay, so before the second topic, you have to know about what is slip, what is rotor frequency, what is rotor current, what is the EMF, what is power factor. Okay, leave this. If you know construction, operation, and also slip and rotor frequency value, rotor EMF value, that is formula, not value, it is a formula, and rotor current and power factor and torque formula, definitely you will answer one question. Okay, so from these parts, from this portion, you will get theory question and also one numerical. Numerical is very, very easy numerical. They will ask you to find out what is slip, what is actual speed, what is synchronous speed, or what is frequency of rotor current, or what is frequency of rotor induced EMF. Very simple substitution from numericals. Very simple substitution numericals. No need to think about the numericals. Just read it and solve it. Very simple numericals. Okay. So, you will get theory from this portion and also one numerical from this portion. Definitely you will get. Okay. If theory not comes from this portion, it comes from this portion, definitely, from speed control method. Okay. So, a total question from 3-phase induction motor, a total question A bit and B bit. A bit is a theory from 3-phase induction motor, B bit is one numerical from 3-phase induction motor, definitely. Okay. So, next choice question, it is from these 3 topics. It is from these 3 topics. Okay. So, if you want to study this or go for this, we have to study what? Construction and operation. It is enough. Construction of synchronous generator, operation of synchronous generator, that is the question. No numerical, only theory question. Am I right? Construction of 3-phase synchronous generator and operation of 3-phase synchronous generator, only theory question from part number 3. Okay. So, you prefer part number 1 and part number 3, definitely you will answer question from unit number 4. Okay. If time permits, go for single phase induction motor and separately excited DC motor. Otherwise, you leave these two machines and read three phase induction motor totally and read this small topic of synchronous generator. That's it. Okay. Use time effectively. Don't spend time to read all the things. You have very less time. I think you forgot all the topics. Maybe 6 or 7 months gone, you forgot all the topics. So that's why I'm repeating. Use your time effectively. Spend less time and gain more knowledge. Okay. You have to spend very less time and you have to gain more knowledge or more information. For that, just open Cynohub. We have only 5 minutes video lessons or 10 minutes video lessons. You just open and watch it. Definitely you will gain the knowledge. No need to open textbook again. I solved numerical. I explained every topic. You just watch it and you just solve one numerical what I have explained. Okay, that's it. Go to examination, write, you will get definitely good marks. Okay. Now come to unit number 5. So unit number 5 is theory question, theory unit, total theory unit, no numerical. Okay. So switch, fuse unit and circuit breaker. That is one topic. Earthing and batteries. That is part 2. And power factor correction. Part 3. Okay. Switch, fuse unit, miniature circuit breaker, earth leakage circuit breaker. Likewise, you have three circuit breakers. Okay. Here the question may comes like explain miniature circuit breaker or explain earth leakage circuit breaker. Okay. And another model is compare earth leakage circuit breaker with miniature circuit breaker. You have to compare the 2 circuit breakers or you have to compare the 3 circuit breakers, or they will ask another model. So what is earth leakage circuit breaker? For an example I am saying, what is earth leakage circuit breaker, and write its advantages and disadvantages. Okay. I will write model questions. One is explanation or explain. Another model is compare. Another one is advantages and disadvantages. Okay. Now you have 4 or 5 instruments: switch, fuse unit, circuit breaker, miniature circuit breaker, earth leakage circuit breaker, and also MCCB. Okay. So for those 4 instruments, first model question is explain, and second model question is compare of 2 circuit breakers or 3 circuit breaker, and third model is its advantages and disadvantages. Enough. Part 1 is enough. No need to study extra one. Okay. Explain or compare or advantages and disadvantages. That's it. Okay. Now come to earthing and batteries. Okay. Normally earthing means they will ask what is the purpose of earthing, or what are the advantages of earthing, and what are the methods of earthing. Okay. Here for earthing they will ask 2 models. Advantages or purpose. Purpose and advantage, those are all same. Okay. Purpose or advantages of earthing, and what are the methods of earthing. That is one. Those are the 2 questions. Purpose and methods of earthing. Come to batteries, you will get 2 model questions. One is characteristics of batteries, and second one is classification of batteries. its chemical equations. Okay, from batteries, listen carefully. Characteristics of batteries, and the second one is classification of batteries with their chemical equations. Okay, so I am repeating from earthing, advantage or purpose of earthing or methods of earthing, and here characteristics of batteries and classification of batteries. So what about here? Explanation of that particular instrument, comparison of two or more instruments, and advantages and disadvantages of those instruments or those equipment. Now come to here, it is a power factor correction, am I right? It is a power factor correction, last topic. Okay, here you will get need of power factor and correction methods, 2 questions. So, need to improve the power factor and how to improve the power factor, 2 models. Need to improve the power factor means, so what are the advantages of high power factor? And what about this next question, correction method, that means how to improve the power factor by using synchronous condenser, by using another equipment. Okay, so based on some methods will improve the power factor. They will ask directly, so what are the power factor corrections? Okay, so that is about your unit number. It is not there. So it is there as a power factor improvement, not a correction, it is an improvement. You know, I said power factor correction means power factor improvement only, because we will have very low power factor. Okay, in is a lagging case, we have to improve it. That means you have to make it to near to 1. Okay, so power factor correction or power factor improvement, those 2 words are same, their purposes are same. Okay, so read these 2 parts, that is switch fuse units, circuit breaker, and model questions are explain the equipment or compare the equipments and its advantages and disadvantages. And here, so what is the purpose of earthing, and what are the methods of earthing, and what are the characteristics of batteries, and what are the classification of batteries with their chemical equations. Please read part number 1 and part number 2, that's it. Definitely you will write one full question from unit number 5. Okay, spend your time effectively. Okay, don't waste your time. Okay, so don't read all the topics. If you feel you have very less time, we are with you. Open Cynohub. We have very small videos, 5 minutes, 7 minutes, 10 minutes. Spend very less time on Cynohub and gain more knowledge and more marks because of Cynohub. Okay. If you have any questions, if you have any doubts, please ask me. I'll clarify it.
So, students are asking if you can explain any theorem in the unit 1.
Yeah.
Like simple ones like KVL or KVL.
Theorem means superposition, Thevenin's. Okay, I'll explain. Superposition, I'll explain. I'll take that example.
Superposition or Thevenin?
Yeah, I'm taking superposition. Yes. Okay, some of you are asking about explanation of any one theorem. Okay, I'll take superposition. Okay, so what is the statement of superposition theorem? Any bilateral linear network having one or more sources, I am repeating, any linear bilateral network having one or more sources, comma, the response in any branch is equal to sum of the responses caused by individual sources acting alone. Sum of the responses caused by individual sources acting alone. Okay, I'll tell you that by taking one practical example. Then I'll go to, I'll take one circuit. Okay. Here, three elements are there. One is you only. Another one is your father. Another one is your mother. So tell me, so how many elements we have? Three elements. One is father, another one is you, another one is mother. Okay. So normally father will give some money to you and mother will also give some money. Okay. So you have 200 rupees. You have 200 rupees. Okay. Now father is giving 150 rupees, mother is giving 50 rupees. Okay. Now what is that? How will you get 200 rupees? You will say, sir, father is giving 150, mother is giving 50, so sum of 150 plus 50 is equal to 200, that is superposition theorem. The response in a branch is equal to sum of the responses caused by individual sources. This is the source 1 and this is the source 2. Am I right? Father is the source, mother is the source. They are giving. They are giving means source. This you or myself or taking means a resistor or a capacitor or an inductor. So we are passive elements, and here these two elements are active elements. Active elements will give, passive element will take. Now this element is taking from father active element, mother active element. And what is the value of this branch? 200 rupees. How? Sum of 150 plus 50. That is the superposition theorem. Okay. Now I'll take a electrical circuit. So I'm considering a small circuit, very simple circuit. Maybe in your class also, sir, I have explained this circuit only. Okay. Oh, sir is explaining same circuit. How? Don't think about that. In textbook they will give us a sample circuit like this only. Okay. Now, so three resistors, source 1 and source 2. Now I want to find out response in R3. Response in R3. What is the statement? Response in any branch is equal to sum of the responses caused by individual sources acting alone. That means one source will be activated and another source will be deactivated. Voltage source will be short circuited, current source will be open circuited. Here I consider only two voltage sources. Okay. So what is step 1? So I am activating V1 source. Now this is R1 and this is R3, and I will calculate I1 current and I will deactivate V2. So I will get I1 here. Okay. Likewise, in step 2, I will activate V2 and I will calculate I2. So, in same branch, so maybe consider it is A and B. So, this is the same branch. So, this is the same branch. Okay. So, by activating V1 source, I am getting I1 current, and by activating V2 source, I am getting I2 current, and sum of these two currents must be equal to the total current. So, I is equal to I1 plus I2. This is the superposition theorem. If you know the current value, you are able to calculate voltage across any resistor. Voltage across R1, voltage across R2, voltage across R3, or power loss at R1, or power loss at R2, power loss at R3. But question is, you have to know what is the current flowing through that branch. Okay. So, this is very simple theorem, superposition theorem. Now, next, if you have any question?
So, same like the example that you have took about the father, mother, and
Yes, yes.
similarly, can we explain the Thevenin circuit just over?
They are asking. Okay. So, here I will draw a family tree. Okay. So, myself, it is myself. Okay. You consider I have 3 children, they have married and they have 3 children, they married and something. This is the family tree. Am I right? If I ask a question, what is this? What is this tree? You consider myself means you take some Shiva. What is this? You say, sir, it is nothing but Shiva's family. Shiva is having 3 children and those children having some, okay, likewise, it's a family tree, Shiva's family tree. Okay. Now, Shiva's son is Rama. Okay. And from Rama, something is here, some Lakshman is there. Okay. Okay. Now, come to here. And what is statement here? After Shiva, what is statement? You will say, sir, up to here, it is Rama's family. Up to here, it is Rama's family. So, total it is Shiva's family, but up to here, it is Rama's family. Okay. That means I am not giving all children names, all father, mother names. Okay. I am concluding that so this portion is Rama's family, or total one is Shiva's family. Likewise, in Thevenins also, you have a huge circuit consisting of more resistors, more inductors and more capacitors. I will draw that circuit. Wait, I will draw that circuit. Some voltage, a resistor, another resistor, another one, here another one, here another one, here another one, and you will get another one here, another one, and here it is another one, here it is another one, now here it is another one, now here it is another one, likewise another resistor and likewise another resistor. And if I ask what is current flowing through this resistor? If I ask question, what is current flowing through this resistor R? And what is current flowing through this resistor R? The circuit, the shown figure. This is the total circuit diagram. If you get same question in external examination, maybe on Monday, what will be the situation? So you have more resistors. If you ask question, current flowing through this resistor means, just you leave that question, you will go for alternative one. Am I right? So likewise, see here. So this total one is Shiva's family. Okay, but from here it is Rama's family. Okay, now same thing, Shiva and Rama. Okay, so here resistor will have voltage. At resistor will have voltage. Now we have to calculate all the equivalent resistance, that is R equivalent. Okay, now based on that we will say, sir, up to here, so you consider this a load resistor, okay, up to here before load resistor, sir, this is the load resistor. So before that everything is concluded by using two parameters, that is voltage across this particular resistor and R equivalent, that is Thevenin's theorem. So I want to calculate current at this particular branch, at that particular parameter. So to calculate current in this particular branch, I have to minimize this circuit except this particular branch. I have to minimize this total circuit into V Thevenins in series with a resistor, that is the Thevenin's theorem. Okay, and one more question. Huh? Load and node transfer. What is transformer? No load and load. That is transformer. Operation. Yeah, it will take more time. Okay, some of you are asking about operation of a transformer on no load case and operation of a transformer on load case. So I'll give some information. Okay, now transformer means it is consisting of primary winding and secondary winding. The winding which is connected to the supply is called primary winding. So this is the primary winding. The winding which is connected to the load is called secondary winding. Now no load case means at secondary side there is a no load, or secondary is not connected to the load. So this is the no load case. What about loaded case? So primary is connected to the supply and secondary is also connected to the load. Okay. Secondary is not connected to the load, it is a no load case. Secondary is connected to the load, it is a load case. Okay. And the operation of no load case is same, or it is used in load case also. Okay. So what is no load case operation? Listen carefully. I'll explain no load case operation and you'll just watch load case operation in Cynohub. It will take more time. It will take 20-25 minutes. Okay, maybe 15 minutes. I think so. Not 20-25. Maybe it is 15 minutes with phasor diagrams. I have drawn phasor diagrams also. Okay. Now this is the input voltage or primary voltage. Now it is given to the primary winding. What happens? What happened? Whenever a voltage is connected to a coil, it acts as a magnet. It is electromagnet. Now magnet means what? It dissipates the flux. Now that flux will move from primary winding to secondary winding. That flux cuts the secondary winding and also primary winding. According to Faraday's laws of electromagnetic induction, whenever a conductor cuts the magnetic flux, EMF will be induced. So here EMF is E1 and here EMF is E2. E1 is self-induced EMF. E2 is mutual induced EMF. Do you know what is self-induced EMF? The EMF is induced because of its own flux. Flux is induced at primary winding. That same flux cuts the primary winding. It is a self-induced EMF. What about mutual induced EMF? Flux is induced at primary winding, but that flux will be cut by the another winding, secondary winding. Okay, it is a mutual induced EMF. That is a no load operation. I have given input voltage, there is inducing of self-induced EMF, and there is inducing of mutual induced EMF, and there is a flow of no load current I naught. That is no load operation, very easy one. Okay. Next, load operation means load is connected. Then so many parameters will comes into the picture, or so many parameters will flow into this transformer. As explained neatly in transformer and load case video. Please open that video and watch it. It takes very less time, but you will gain more knowledge by watching that video. Any more? Star delta? Small problem. Okay. Okay. So some of you are asking about star delta connections and some model numerical. Okay. Star connection is like this. Okay. I will take it is A, it is B, and it is C, and it is neutral, and I will take A as a line. Okay. Line to line will get line voltage, line to neutral will get a phase voltage. Line to line will get line voltage, line to neutral will get phase voltage, and this is the line current and this is the phase current. So in star connection, what are the conclusions? Line voltage is equal to √3 V phase, line current is equal to phase current. Line current is equal to phase current. Now listen here. Some problems will consisting of this element as a resistance, maybe 20 ohms, 20 ohms, 20 ohms, balanced circuit, because you have only balanced circuit. Okay, and line voltage is something 440 volts. They will ask you to calculate what is the phase current. What is the phase current? So tell me, what is the phase current? Okay, phase current is nothing but V phase by 20 ohms. Am I right? Now I phase is equal to V phase by resistance. V phase value is how much? From this formula, V phase is equal to VL by √3. VL by √3 by what is the resistance value? It is a 20 ohm. What is the VL value? It is a 440 by √3 by 20 ohm. You will get I phase. Okay. In star connection, IL is equal to I phase likewise, and they will ask what is the phase power. That means P is equal to V phase I phase, 3 into V phase I phase into cos phi. You have to use this formula and you have to solve. Okay. Likewise delta connection also. Okay. If you want, you just go through the videos of star connected and delta connected 3-phase systems. Any more? 3-phase? Induction motor.
Just a brief
Yeah, they're asking heavy topics. Anyway, you are a student, I'm a faculty. My work is to satisfy you. I'll spend more time on you. Okay. So, what do you want, the operation of a three-phase induction motor? What do you want, operation of a three-phase induction motor? Anything else? Operation? First, you have to know what is induction. Induction, electromagnetic induction. It is like a transformer operation. Okay. What is transformer? Power will transfer from one circuit to another circuit without any electrical connection but through magnetic. Okay. Here also in operation, power will transfer from one circuit to another circuit without any electrical connection but through magnetic connection. Okay. So, I will explain that operation of a three-phase induction. Just I will give some brief, okay, because so we have very less time. Okay. First, I will give diagram of three-phase induction motor, then I will go for operation. Now, normally all electrical machines except transformer consisting of a stator. Okay. So, stator will have stator winding and there is a rotor also. Okay. Now, it is three-phase supply, means the stator winding is connected in star mode or likewise star mode. Just before explain star connection. So, star mode. Okay. Here you will have one pole and here you have another pole and here you will have another pole and opposite to this here one, opposite to this here one and opposite to this here one. Okay. So, this is R dash and this is Y dash and this is B dash and we will have a winding also. Okay. So, stator poles and stator winding and this is the three-phase supply. Three-phase supply. Okay, that is about the stator. Next, there is a rotor. So, we have two rotors, squirrel cage rotor and slip ring rotor. Here I am considering a squirrel cage rotor, that is the rotor is short circuited, okay, and a shaft. So, what is motor principle? Motor converts electrical energy into mechanical energy, that is why shaft. This is the output, rotation is the output and taking electrical energy is the input. Now, it is taking electrical energy and giving mechanical energy, hence statement is satisfied. Motor converts electrical energy into mechanical energy. Okay. Now, just listen. Whenever a three-phase supply is given to the stator poles, whenever a three-phase supply is given to the stator poles, there is a producing of rotating magnetic field. There is a producing of rotating magnetic field. What is rotating magnetic field? There is a video. Okay, I explained by considering all the vector diagrams and explained what is a rotating magnetic field. It is also one of the important question. So, all electrical people will get a rotating magnetic field. Okay. So, whenever a three-phase supply is given to the stator poles, there is a production of rotating magnetic field. Now, this, the name tells rotating magnetic field, that means magnetic field is rotating. Are understanding me? Rotating magnetic field means magnetic field is rotating. At what speed it is rotating? That is the question. That speed is synchronous speed. That speed is synchronous speed. Now tell me, whenever three-phase supply is given to the stator winding, a rotating magnetic field is produced and it is rotating at a speed of ns. Ns is called synchronous speed. Okay. Now this is the magnetic flux. Now this is the conductor and this is the magnetic flux. Now according to Faraday's laws of automatic induction, whenever a conductor cuts the magnetic flux, EMF will be induced. Now this is the flux and this is the conductor and these two will cut each other and there is a induced EMF in a rotor and rotor is short circuited, hence current will flow through that rotor. I am repeating. There is a flux cutting action by rotor conductors, hence EMF will be induced according to Faraday's law. Now this rotor is a short circuited one because I consider squirrel cage rotor, hence current will flow through that short circuited rotor. Okay. Now DC motor principle. Whenever a current carrying conductor placed in a magnetic flux, it experiences a force. That means now rotor conductors or in rotor conductors current is flowing. Now those rotor conductors will experience a force. That means they are trying to rotate. They are trying to rotate. At what speeds they will rotate? They will rotate at less than synchronous speed. Less than synchronous speed. Okay. So that is the operation of a three-phase induction motor. Three-phase supply, we have to give three-phase supply and there is a production of rotating magnetic field. It rotates at synchronous speed. This field will cut the rotor conductors and there is induction of rotor EMF and rotor current. Hence, according to DC motor principle, whenever current carrying conductor is placed in a magnetic flux, it experiences a force, hence this rotor will rotate less than synchronous speed. Okay. So that is the operation of three-phase induction motor. Any more doubts? Close. Okay. If you have any more doubts, please post in Cynohub. Okay, we'll answer it. Okay. And if you have, or you are not able to answer it, we will cite you a video there. Okay, you just go through that video and watch it. Definitely you will understand that topic. Okay, so don't think about they are doing business, that's why they are saying so many times. Okay, we are not doing business. We are sharing the information. We are sharing the knowledge with less cost. Okay, our cost is less than a cinema ticket. Okay, please watch the videos and get the knowledge. Thank you very much.